Alright, statistics. So we say that statistics is the study of, it says the branch of mathematics that studies the collection of data in numerical form. It says the branch of mathematics that studies, or it says deals with the collection of data in numerical form. Full stop. The data collected are analyzed. The data collected analyze, process for use. Analyze, process for use. Full stop. So that's just an introductory part. Under these statistics, we have what we call the descriptive or descriptive. So as an Igbo man, so English is descriptive. So we have what we call the analytical statistics. Nobody's ever going to be asking all this definition, even though it matters for the So, but we can't just rush and go to the main thing without passing through all this. So, when it has to do with descriptive, we simply say that it's simply data at hand. Data at hand, or you say few data. So, it has to do with collection of data, or a branch of mathematics that deals with collection of data that is very few. So when you're talking about the qualitative analysis of data, you're looking at descriptive data. But the minute that data becomes too large, that you can't just handle it at a spot, you now start to look at what we call analytical statistics. So we say that analytical statistics is a type of statistics that deals with quantitative analysis of information, or you say large data. So when you know this, the next thing you need to know, if you notice I've been calling data. So the next thing you need to know is what we call sources of data. And data in itself is information. So sources of data, we have what we call the primary source of data. The primary source and the secondary source. The primary source of data and the secondary source. So if something is happening, or if there's an information that is happening, let's say something happens here, police just enter here, arrest your friend. You witness it, how it happened. To you, it's a primary source of data. Whoever you're giving that information, it is coming from the direct person or direct witness. It says the primary data. But if, for example, the person that gave this information give it to another person, and that person now has to publish it, put it in an article or newspaper, it becomes a secondary data. So we say that primary source of data is a type of data that is coming directly from an incident or event. So it is coming directly from an incident, from an event, from an account. So we say that such a data is a primary source, directly from the witness. But secondary data are data types that comes from a third party, newspaper publications, journalism, etc. So under the primary data, you can write example of primary data is information from government house, census, so just direct cases. There are so many of them, and it's not something you come and start painting in such a way that it looks too English. Just you understanding what it is means you can raise a lot of examples under it. So that is for primary source. So a question can come, they tell you a data that comes from government house or whatever it is a what type of data? It's a primary data. A data that comes from newspaper publication, journalism is a what type of data? Secondary data. So we need to know that. So with that said, that's just trying to run through the introduction part. This is not the main thing, but just so now we have what we call classification. classification and tabulation of data. So for your level, that's at 22112. What we are treating is introduction to statistics, which is what we are doing now. Then today we also do measures of location, also called measure of central tendency, measure of location. We also do measure of dispersion. Then the third one, the fourth one that we will do. But if time doesn't permit us, we will shift it to later because this probability is very big and I would like to do it as a topic on this one. So start 1, 2, 1, 1, 2. All those things they wrote there for you, all those things fall under these 4 major topics. So that's, we treat the first 3 with carefulness. You understand everything to it, all of it. Then next Saturday, we do probability. So probability is a course on this one because under this probability we have permutation and combination. It's a big topic. So I want to do it as a topic on this one. So if you know that we said that we have classification and tabulation of data. So if we have classification and tabulation of data, you need to note that for the tabulation, that is what you call tables. You see sometimes in your secondary school they tell you about frequency table, cumulative frequency table, all those things. Those are what we call the tabulation techniques. So I would say that classification and tabulation is done so that you are able to organize those information. So the idea of statistics is simply putting information or data in such a way that I don't have to stress about it when I look at it a second time. It is ordered. So if I know that for this classification and tabulation, we have the first one. The first one is what we call the display diagram. Display diagram. So all these things are things that will take us to what we are looking for. Display diagram, that's the first one. And under this display diagram, you have what we call pictogram. Under this display diagram, you have what we call pictogram. Under this thing, we have what we call bar diagrams as well. Under this display diagram, we have what we call bar diagrams. And under these bar diagrams, we have what we call bar charts. I will teach you all these things and how to do it. Histogram, line graph. Then we move to the next one. We have what we call circle or sector diagram. Under this display diagram, circle or sectional diagram. And this circle or sectional diagram is also known as what we call pie charts. Pie charts. So this is for display. That is, in order to process, put information, I told the statistics has to do with arrangement of information so that it is organized. You don't do it in such a way that if you see it today, they tell you, okay, this is how it is. Tomorrow, if you come and look at it, you don't understand it today. It's not from the beginning. So that is the reason why all these ideas are there. So in order to classify and process information so I can understand it, we need to do all these things. So if I've noted the first classification, the second one is what we call frequency table. Or it's a frequency distribution table. Frequency table. So it's important to note all these things because once we start calculation under this, I wouldn't want to be repeating it. So I said for today we are treating this. Next Saturday we do only probability. Probability is like the word of this whole. So frequency table. We need to know how to do this frequency table. We need to know when it's grouped data and when it's ungrouped data. How do we go about it? Now number 3. We have what we call the cumulative frequency table. We need to know how to do all these things. Cumulative frequency table. How do we go about it? What is it? Cumulative frequency table. Number 4, under this tabulation and classification, I want to now play this thing because you're talking it. So number 4. Number 4 is what we call class interval. Class interval. Class boundary. You need to know all the differences. We need to also know what we call upper class boundary and lower class boundary. So upper and lower class boundary, we need to know what is the difference. Lower class boundary. This is under introduction to statistics. I've not started location and measures of dispersion. Now number 7, we have what we call class width, or we call it class size. Class width / class size. We also have what we call upper class limit and lower class limit. Upper and lower class limits. Number 9, in order for classification and tabulation, we have what we call grouped data and ungrouped data. We have what we call the discrete data. Alright, so I just want to play this up now so I can explain each one of these. Then we take examples under it before we move to measures of prediction. So the first one, pictogram. When you hear somebody tell you about pictogram, the person is simply talking about a caricature or a picture representation of information. You will see sometimes if you are scrolling through TikTok or Facebook, so they will come and tell you, Nigeria in 2024 sold 12 tons or you say 12 gallons of crude oil. You come and see maybe the raw gallon like this, maybe a rough sketch. They come and tell you Nigeria made up to 78% in the revenue. They now come and tell you the Victoria Guinea sold in the same year. They come and draw a smaller gallon. They tell you this, maybe this song still small. They tell you sold like 2%, made 2% in revenue. So the idea of using pictures, caricatures, cartoons to illustrate information is what we call pictogram. You don't need to be making special measurements or taking note of the measurements when we are doing pictogram. But when we now move to what we call bar diagrams, we now need to make measurements of that. So the first bar diagram, so I said pictogram is simply using pictures, caricatures, diagrams, yes, like rough sketch of events, that is diagrams, to make representation of data or information. So that is pictogram. So let's go to the next one, which is bar diagrams. Under bar diagrams, we have bar charts, histogram, line graph. Now, in order to draw a bar diagram, that is a bar chart, you need to note that a bar chart is a diagram that is drawn using a rectangle or a block whose vertical axis will have the frequency value, and the horizontal axis will have the midpoints for a group data. I know I'm too fast. Am I too fast? I said for a bar chart, it is the representation of information using rectangle or blocks. Full stop. The vertical axis will always be drawn using frequency values. It is the representation of information or data using rectangles or blocks. The vertical axis will always be drawn using frequency values, while the horizontal axis will always be drawn using midpoints, or they call it class mark. Another name for midpoint is class mark. My God, I did not put it here. Another name for class mark is midpoint. So when you write using on the horizontal axis, you have class mark or midpoint. You now open bracket and write, this is for grouped data. This is for grouped data. We'll start taking examples soon, you understand it better. So you open bracket, this is for grouped data. You close the brackets. Then you write comma and no need putting comma and, or you say or x values for all group data, or x values for ungrouped data, or nth values for ungrouped data. Just copy. As we start taking examples, you will understand this. Or x values for ungrouped data. Now, full stop. Note, the major difference between bar charts and histogram is that for a bar chart, there will always be spacing between the blocks. The major difference between a bar chart and a histogram is that for a bar chart, there will always be spacing between the rectangles. There will always be spacing between the rectangles. Okay. I want us to take an example so that we understand that bar chart. So you can write. So before we move to histogram and line graph, let's just take an example under that so that it makes more sense than piling together. So see what I have. I am given scores, and these scores are given. They tell me that I have 0 to 9, I have 10 to 19, I have 20 to 29, I have 30 to 39, I have 40 to 49, and I have 50 to 59. This is a group. So they are telling me that there are people that scored from 0 to 9. There are people that scored from 10 to 19. There are people that scored 20 to 29. There are people that scored 30 to 39. People that scored, and how do I know that those numbers are real? They will come and give me what we call frequency. I will say that, unlike in physics, where we say frequency is simply number of oscillations at a given time. Here, frequency is simply two things. Either it's talking about number of events, or number of people. Number of events or number of people is 1. Then 2, frequency also means time, or is a number of occurrence. So time of something happening, the number of times. So first, number of people, number of events 1, or it's a number of time, that is occurrence 2. So if I've noted that, so this is a score, then I give me that people that scored 0 to 9 is 10 persons. The people that scored 10 to 19 is 5. 20 to 29 is 7. This is 10. This is 8. And this is 4. Now, this thing that I have here is what we call a class. Even if you see scores or you see anything, maybe age, maybe group, whatever, but for the fact that it has to do with something to something, it's called a class, or you call it a class boundary. Now, when you have a class boundary, anytime you're giving information as class boundary, because they would have as well given you that you have maybe people that scored 9, 10, 19, 29, maybe one person scored this, 10 person, 19, or you come and see maybe 9 here, or like this, and it's not grouped into a class. This is an ungrouped data. So once any information you are given does not have a class, it's an ungrouped data. And once you have the grouped data, anything you have towards the right hand side, maybe this is from this to this. What you have on this is what we call the upper limits, and what you have here is what we call the lower limits. So the left hand side of a class is called the lower limit, and the right hand side of a class is called the upper limits. So if you've noted this, you also need to know, because before we start using this to process information, I want you to know what all these things are, so that we can now draw bar charts, then draw histogram, you see the difference, draw line graph, then draw pie chart, you see the difference, and that will be it for the introduction of statistics. We'll now move to measures of prediction. So if I have this 0 to 9, 0 to 9, by the time I do 9 minus 0 is 9, right? If I do 19 minus 10, that is upper limit minus lower limit. 29 minus 20, upper limit minus lower limit. This thing that I'm doing is what we call class width or class size. So the difference between upper limit and lower limit is known as class size. Difference between upper limit, lower limit is known as class size, or we call it class width. Now that you've noted that, you've now learned what is upper limit, what is lower limit, what is class size, also called class width. and then you now know what frequency is. That in statistics it simply talks about times of occurrence, or it's a number of occurrence, then number of people or number of events. So if you know that, we move to the next one. And the next one is simply what we call class interval. Class interval, sometimes represented with I. Class interval is simply the difference between two successive upper class boundaries. The difference between two successive upper class boundaries is known as class interval. So if I have 29, 29 is a class, that is the upper boundary of a class above this particular class. So if this is the second class, this is the third class, this class is not like this one. So if that is true, to get the class interval is simply doing the upper class boundary of this class, the third class, minus the upper class boundary of the second class. To get the upper boundary, the class interval of these two classes, of this, it's always between two classes. You simply say, upper class boundary of this is 59, this one is 49, this minus this. That means it's the same. And in such a case, we say it's a group data. It can be different sometimes. The case here is different. We call it discrete data. We'll get here. So notes, write it in your notebook. Class interval is simply the difference between two successive upper class boundaries. Class interval is the difference between two successive upper class boundaries. That's class interval. So we've treated, you don't know what is class interval, you don't know what is class width or class size. There is simply the difference between upper limit and lower limit. Now you know what is class boundary. Class boundary is simply having a class or having a group, that is having that you belong to maybe 0 to 9 or 0 to anything, that's class boundary. Having lower limit and upper limit. Now, the next one, so upper and lower class boundary. The next one is simply upper and lower class boundary is simply talking about adding 0.5 to the upper class limit and subtracting 0.5 to the lower class limit. When you have 0 is 0. So see what I mean? For lower class boundary of this now and the upper class boundary, it will simply be 0 is 0, don't be subtracting anything from it. But the upper class boundary of this, so you add 0.5 to this, it becomes 9.5. Now, for this, to get the lower class boundary, so Toge is your friend. Okay. To get the lower class boundary of this, is simply subtract 0.5. So what you are doing when you are talking about upper class boundary and lower class boundary is simply subtract 0.5 from the lower class boundary, add 0.5 to the upper class boundary, or you say to upper class limits. So upper class limits, sorry, use upper class limits, not, well, yes, because if you use upper class boundary, you're talking about it. So I said you remove 0.5 from the lower class limits, this is a limit, and add 0.5 to the upper class limits, so you don't confuse it. So upper class boundary now will become 19.5, and this will become 9.5. This one will become 19.5. This one will become 29.5. So add 0.5 to the upper class limits. Remove 0.5 to the lower from the lower class limits. So this will now become 29.5. This will become 39.5. This will become 39.5. This will become 49.5. And if you observe and you notice that the minute you find the upper class boundary of a class, it becomes the lower boundary of the other class, lower class boundary of the other class. So this now will become 49, which is 0.5 for this one. Then this will become 59.5. So if you observe it, there are so many things you observe with this course, because it's a course that you can easily do, like you can easily just do tricks when you start seeing things here. So with that said, we've gotten to know what is upper class boundary and lower class boundary. We now know this as well. So when it's group data, we say that something is group data when it has a class. When it has an upper limit and a lower limit, it's a group data. While if something is given to you without having a class, It is simply an ungrouped data. Now, discrete data is simply any collection of information. Remember, we said statistics is the collection of information, or is a type of branch of mathematics that deals with the collection of data in numerical form. So anything you have when it has to do with statistics, we are saying, how do we take all those things to numerical form so that we can be able to give count of what it is? That is statistics for you. That is why computer programmers, I program, the apps I've been sending the semester, I'm the one that design most of those apps. So every programmer or computer scientist must do statistics properly. You do it repeatedly. That's why in some schools, you have it to the computer and statistics departments. It's just that they suits. We are putting everybody. I know as you progress, things will still change. So if you know that, it simply means that everything there is to group data, you understand it, that we're going to be treating this when we are drawing as group data because we have a class for it. But actually they gave it to us just like that with that class, it's on group data. Now discrete simply means when I don't know the next thing to come after each value, after a value, when I don't know the next thing after a value, that is discrete data. See what I mean? If I have, for example, here, you see that this is 0 to 9, 10 to 19, 20 to 29. So discrete data is a type of ungrouped data that doesn't give count of the next value. So you say that for a discrete data, if I have, for example, 0, 1, this is information, and I see 2, then maybe you want to see another number that should be 3, progressive. Then you come and see maybe 5, 8, then maybe you come and see 3 going on. So you can see that this type of information, we don't actually know that this, even if I carry this and put here now to the 3, here is 4, but I have 5, and you can't force 4 to enter here because it's not all the information is given to you. So for that reason, we say that a type of ungrouped data where I don't know the next events is known as discrete data. So if I've noted that, the last one I want us to do is, before we now start solving, differentiating this, is the class mark or moot point. And remember, this is introduction to statistics. We now move after that to measures of negation before measures of dispersion. Then the last one will be probability. So under probability, you have this combination, permutation, binomial theory, binomial expansion, and stem, all those things. So the class mark for anything class mark is simply midpoints. So another way to put class mark is either you call it X. Class mark is also X. So for an ungrouped data, let's say I was given these things like this. It becomes an ungrouped data automatically. That means my X will just be this thing. This will just be my X. But once you have a grouped data, you can't use this as your X now because it's now between a range. You don't know exactly what to hold hand and say that is your X. You need a main thing. You need something to hold hand to. So for that reason, what I was simply do is to find the midpoint of each of this class. So I will simply say 0 plus 9 is 9. Divided by 2, you get 4.5. Now 10 plus 19 is 29. Divided by 2, you are getting around 14.5. Is it true? So another way to do it is to simply say, let me just be adding 24. Since their class width is the same, since their class size is the same, 9, because this minus this is simply 9. So I can just say, since they are the same, divided by 2, then be adding to the lower class limit. Or we simply note that class mark is simply given by, you can note it as a formula, upper, or you say lower class limits, lower limits plus upper limits divided by 2. So that's the formula. So note that. So now that I've been able to talk about everything here, I can clean it. So now you know class mark now what it is. So for every group data, you don't make use of X. Rather, you make use of X to be the class, you make use of class mark to be your X. You find the center. So this becomes 34.5, 44.5, and 54.5. So if this is the case, we can now start working because we now know everything. So before I move to working it out, there is one again, cumulative frequency table. In order to do cumulative frequency, what is cumulative frequency? In order to do cumulative frequency, still under introduction to statistics, everything. In order to do cumulative frequency, it is simply the successive addition of frequency at each point. The successive addition of given frequency at each point. See what I mean? For the first frequency, it is 3. First frequency is 3. So the first frequency will always be the same with the cumulative frequency. Now do 3 plus 5 is 8, right? I have 8. Now 8 plus 7 is what? Is it 15? Is it 15? Now 15 plus 10 is what? 25, right? Now 25 plus 8 is what? Is it 33? Yeah? 33 plus 4 is what? Is it 38 or 37? 37. So that is what cumulative frequency is. It is simply the successive addition of the frequencies at each point. Or you say before each point. The successive addition of frequencies before each point. So simply do the first frequency will always be the same with the cumulative frequency. So from there you add. You get the next one. From there you add, you get the next one. From there you add, you get the next one. From there you add, you get the next one. From there you add, you get the next one. So that is cumulative frequency. And this cumulative frequency always helps you total your frequency. By the time you come to this now, this is 37. If you go and sum up this frequency, you notice that this frequency will be 37. The last value you have, it doesn't mean that cumulative frequency adds up to frequency, but it tells you the last value of your frequency tells you the total of your frequency. Sorry, the last value of your cumulative frequency tells you the total of your frequency. So if you check, by the time you do the sum of this frequency, you should be having 37. If you punch it, this will give you 37. I did not say, because students always mistake it. I did not say the addition of cumulative frequency gives me frequency. No, I said the last value of your cumulative frequency gives you the summation of your frequency. So if you sum this frequency up, you get 37 and this is 37. So it will always be the same. So now we've noted all those things. Now let's go to the diagram, the calculations aspect of this. So the first one, pictogram is not among, because I said that you don't need to analyze or take measurement of pictogram. It's a correct capture. You can use diagram. If you want to say, my friend that looks like this, he has blonde hair, or he has this one. Once you are using picture to show anything, that's the part of statistics. You want to show how many persons involved, part of statistics. So you don't really start making measurements with this. So our goal, our focus will be on difference between bar diagram and circle diagram. Once we are done with that, we'll now move to measures of equation. So for bar charts, in order to do bar chart, I said that the vertical axis will always be drawn using frequency. Vertical axis will always be drawn using the values you have for that frequency. While the horizontal axis will always be drawn so this will always be done using frequency. And this will always be done using class mark, or you say midpoint. So it's either you call it X or you call it M1 to remember it. Me, I like using M1 for my own, so that I remember it's talking about mark. Why X? I use X when it's an ungrouped data. Remember that for grouped data, M will always replace x. But for ungrouped data, you have your x. That is why when we get to all those versions of notation, you see things like EFX or EF. This is when it's ungrouped data. But once it's grouped data, you put this to remember it that M always takes place of x. You get there. So with that said, I put my M. So knowing that this is grouped data, let me replace it with M. So now, in order to do this bar chart, I will call this is 3. The highest one in here is 10. So the same way we plot graph, I can say let this be 0. You know how to plot graph already. 2, 4, 6, 8. Okay, since it's 10, it's small. I can actually start with 1, 2, 3. This is not big. Okay, so this is for the vertical axis. We always have frequency. Now, on the horizontal axis, you are going to put a class mark. But how you do this class mark is first of all, making sure that there is room for space. And please, mind you that the measurement you are putting here, you are the one choosing it. So let's say I come here and I mark out 2 centimeters. It's up to you to make any measurement of your choice. You're the one choosing. Now, if I mark out these 2, before I mark out another 2, assuming it's histogram I want to draw, I'll just be marking out 2, 2, gap. I won't give any space, 2 to up. But when it's bar chart I want to do, or line graph, if I mark out the 2, let's say I give 1 centimeter gap here. Let me use something like this to show the gap. Before I do another 2 centimeters, then I will mark out another gap. So the difference between histogram and bar chart is that bar chart will always have this rectangle having space. But if it's histogram, it will come and join together, even if it will join. So how do you get that space? Is by making sure that when you are marking out in the beginning, you are making room for that space. Whatever you are using for your rectangle, the measurement you are using for your rectangle is up to you. Nobody's questioning that one. It's entirely up to you. So let's say that when I started this, I gave that 1 centimeter gap as well. So since it's 1 centimeter, let's do 1 centimeter. So let's mark this out. How you do this is to count the number of 1, 2, 3, 4, 5, 6. So I need to have 1, 2, 3, 4, 5, and 6. So now that you've done this, you've marked out. Another person can choose to use 3 centimeters to do his own rectangle. Maybe this space to 3. Another person 4. You me I'm using 2. Depends on you. Nobody is querying you about the measurement you use for a rectangle. But what you will be querying for is spacing. Your bar chart must have spacing. On the histogram, because when we get here, I will show you why and how to do it. Now, I gave this spacing on the starting, even though it's small, but to understand that it should be the same. I didn't remember it when we started. So now, you will now call your first one, the midpoint, the midpoint is 4.5. So, I'll mark out 4.5. The midpoint is 14.5, 24.5, 34.5. 44.5, 54.5. Now, once you are done with marking out that midpoint, you can now call and say the first one, the frequency there is 3. So I can call this is 3. And all these things is the block rectangle I did for the first one. Using your meter, make it straight, make it neat. then you join. The way you normally do your graphic from this point to this point. So then, come again, the next one for the 14.5 axis, it's splitting this at 5. So I can come here, just locate this. When I locate it, using my meter to project this, then join this. Should be straight. Anybody might need to want to see that it's organized. The cleanliness is what is used in judging you. Then those lines you trace should be straight lines. Used to trace should be straight lines. Now the next one is having 7 as its frequency. So I go. I'm using free hand, so your whole should be straight. Then the next one for this rectangle is at 10. I'm removing the dots I used to trace because your whole should be faint. Now the next one for 4.5 is at 8. Place your meter will locate it. Once you locate it, now the last one is at 4. So once you locate it, that is it. So you run the bar chart, the bar diagram, just like that. Then you remember to come and write the scale you use. So this is 2 centimeters is to 1 unit. And this one now, the difference between each one here is 4.5. So this one should be whatever centimeter you use is to 2 centimeters. Let's say me I'm using 2 centimeters is to 4.5 units. So don't forget that. So very simple like that. That is for bar charts. But assuming I want to do histogram, before histogram, let's do line graph. See, bar chart is the same thing as line graph. The only difference is that line graph is a display diagram, a statistical display diagram without thickness, or you say without rectangles. So it has no thickness. So what I mean by thickness is that it only starts from the center. It points to the center. This line graph I want to do. I say it's a statistical display diagram without thickness. So if you start from the center and project a line, just a line up like this, then remove this thing that I did here. All these things I did. What you've done is a line graph for this one. So it's a statistical display diagram without thickness. It doesn't have that thickness that bar chart and histogram has. So if I come from the center, from that midpoint, that is what you use midpoint, draw a line like this. If I remove this thing, so every bar diagram, every bar chart, you always use that class mark, that midpoint, because in a bar chart, you have a line graph. So the center that you have is telling you that the center is a line graph. So let's project this one now. So the only difference between line graph and bar chart is that line graph does not have thickness. It's just a line projected from the midpoint. Why bar chart does have the thickness? So, but the two are the same. So you draw a line graph from a bar chart because you need to know that the line graph will always have spacing. Unlike this program, of all the rectangle of block display, it's only this program that does not have spacing. So if I project this center up to that point, that frequency, remove the thickness. So if you learn this thing properly, you don't even have to be drawing bar chart when it has to line graph. All you need to do is just find the center, give spacing. Then from the center points, just as we did that, you project the lines. This is a line graph. This is a line graph. So the last one under bar or rectangle display is what we call histogram. So I want to use this data as well to do histogram. Then I will use it to do pie chart as well. In that case, we've covered all the display diagrams. Then we move to what we call measures of communication, or we call it central tendency. So I'm trying to say that before we get tired, before 2, we should have covered measure of location, then enter measure of dispersion, then go next week Saturday we do probability. I want to clean. Can I clean? Are we done? Okay. So the only difference between histogram and bar chart is just horizontal axis. And you need to know why. The horizontal axis for a histogram is drawn not with class mark, not with midpoint, but with class boundary. With class boundary. So that's the first thing you need to note. The horizontal axis of a histogram is drawn with class boundary. Okay, give me water. I see. Let's start. And also, so you can note the differences between histogram and bar chart is 1. Horizontal axis of a histogram is drawn with class boundary. 2. Histogram does not have space in between the rectangles. The block or rectangles does not have spacing. So 1, it is drawn with class boundary. 2, it does not have spacing. So let's apply that. So let's say I have, but my vertical axis for histogram will always be drawn with frequency. Always. This thing is, those days, SS2 top 10. They like doing it in SS2 top 10. Those days, I learned that for now. So class boundary. So let me write it CB, class boundary. Now, what do I mean by class boundary? If this is 0, I will now come. What is my class boundary? 0 to 9. Just come and write 9. Now, how do you know that you don't have to do spacing? When you are writing this, write 9 here, 9 comma, the next limit is 10. So write 9 comma 10. You give the same amount of spacing you give here, then this will be your upper limit here 19. You write 19 comma, this is 20. So you give another spacing. The upper limit here is 29. You write 29. Instead of writing just 29, you comma, the next one is 30. So this will be a guide so that you know why you don't give space. It's more like he's saying, it's just like Hausa man's house. Majority of houses in Hausa land. You will see if they build a house here. All this one that will give space to build another house in east. You see that the house is just attached to the next one. No spaces. So it's more like say you get here, instead of giving space, come and attach yourself immediately. So that is histogram for you. So this is 30, give space. So 39. Now comma 4. Then give the same space. Now 49 comma 50. Then the last one 59. So this is how you note histogram. Using comma. Where this one is stopping, the next one is starting immediately. You use our summer and house to remember it. So then the next thing now is to locate each point. For this 0 to 9 is at 3. So I can now come and say this is 3. This is to this point. Now the next one, 10 to 19 is at 5. So this 10 to 19 is at 5. Rotate it fence line. Project it up. I'm removing my own. I'm cleaning the traces so you know it's supposed to be fence line. Then 20 to 29 is at 7. straight line because I'm on the ball. The ball should be straight. Then 40 to 49 is like 8. Then the last one, 50 to 59, is at 4. This is histogram for you. This is how you draw histogram. So we plotted it. There are so many things we can do to histogram, so many things we can do to bar chart, but I don't want us to do anything to it now till we get to measures of location. We use examples here because as we progress, they will start telling you measures of location. Find goal, find mean, find anything. Then they can tell you from a histogram, find node. Mode is simply class with the highest frequency. This has the highest frequency. So to find mode is simply come here, the class before it. Draw a line or an arc to touch this S2, that is to locate the diagonal. From here, the other one to touch this, put the diagonal inside. The points of intersection now, if I place this up, then rotate it down. Any point it means here, using your graph notebook, that is the mode. So when they ask you, using a histogram, find mode, this is how to go about it. And remember, this side is also called abscissa. While this side is also called ordinates. So you can see in the textbook, the abscissa you locate when you make these diagonals. The abscissa located using the point of intersection is what we call the mode. So when we now move to measure of location and we start doing median, I will also teach you how to locate median using histogram. And then there's another one which we call cumulative frequency curve or polygon, also known as ogive. Some people call it ogive. So see, notice that everything I've been using here is frequency shading on the vertical axis. Whenever you have to draw, because your question will ask you to draw diagram, and the diagrams you are going to draw will be within these diagrams I'm giving you now. So it's important to note it. So the last one I want to give is what we call cumulative frequency curve or polygon. Yes. So how you do that one is that for a cumulative frequency curve or polygon, what you use on the vertical axis is your cumulative frequency, while what you use on the horizontal axis is your upper class number. I said the last type of diagram to draw under statistics is what we call the cumulative frequency curve, or we call it the cumulative frequency polygon. If they ask you, one of these is also known as ogive, O-G-I-V-E. You come in the option, you see cumulative frequency curve, you see cumulative frequency polygon. Choose cumulative frequency curve. Most times we call it cumulative frequency curve or polygon, but the one that is also known as ogive or ogive is the curve. So note that. So if I've noted this, I said to draw cumulative frequency curve, we use this on the vertical axis, this on the horizontal axis. So let's draw a cumulative frequency curve for this, using this distribution given to us. So once we are done with that, we can now enter measure of location. And the most important one is measure of dispersion, because that's where they ask most questions, because that's the one that is more difficult. And if you notice, even in physics, that's the one that enters. Then you start to see things like deviation, absolute mean deviation, standard deviation, coefficient of variation, skewness, kurtosis, percentile, decile, quartiles, interquartile range, semi-quartile range. All those ones fall under measure of dispersion. So this is going to be done using upper class boundary. This is going to be done using cumulative frequency. So I notice the highest point here is 37. So I can do it with 5, 5, 0. Let's go with 5, 10, 15, 20, 25, 30, 35. Let's say this is 40. So now, please remember what I said use for each one. Don't mix it up so it doesn't confuse you. So for here, we use the upper class pattern. So I can give any space. It's just like histogram. Cumulative frequency. The horizontal axis is just like histogram in the sense that we don't give any space. We don't, if we get this, we give small space before another one. Together, just once I come and mark out 9.5. Just the same measurements. The next one, 19.5. You don't come and check mathematically to go and start doing, putting it in range, doing this, maybe 5, 10, no, use the upper class pattern like that. Give your space. 29.5. 29.5. It's not like saying that. Should you know that the difference between this and this is also class interval. The difference between anything that has to do with upper boundary, this upper class boundary or upper limits. The difference between anything that has to do with upper is what we call class interval. So if I come and say, that time we said here, we said here, 19 minus 9 is 9 now. That's our class interval. Now if I want to do for the upper class boundary, the interval for the upper class boundary, how to do it is simply 19.5 minus 9.5. I get it. So another way to think of it, if you can't remember upper class boundary, you can just say the upper class interval. The upper class interval is another way to remember it. Because this thing we're actually saying the upper class interval. This is different from this. The gap from here to here is the difference. So however you want to remember it, that's my point. Now when you finish doing this, the next thing to do is to now come and start doing 9.5. 9.5 here is having cumulative frequency for this instead. So you're plotting this against this. Don't confuse it. So of course the 9.5 is having that thing should fall in between somewhere here. Therefore you already know how to talk that. So this time around you are not drawing a box. What you are doing is you are marking out stages, you are marking out points. Once you mark out that point, you've noted that this is like 3. The next one, 19.5, is located under 5. Let's say this is 3. So this is like 5. Come on, mark it out. Then the next one. Sorry. 0. What am I doing? 0. There you go. Confusion. Let me clean this. Shall we repeat this? Let me just clean this. Confusion wants to clean it. So this is 3. Okay. Then 19.5 we can correct. So now the next one, 29.5. 15. So you see something. I keep going here, which is wrong. It's just these two. It's just between these two. So please let's go back again. 9.5 is 3. 19.5 is supposed to be 8. So let's say my 8 is somewhere here. So another way to do it so you don't get confused is anyone you've noted you not against anyone, you bring out the table for you to say playful. So it doesn't confuse you. So 29.5 is 15. Now, please, if you are not following your come attention. Now, the 9.5 is 25. So 37, let's say I have somewhere here. I always claim this because I want you to know that your own should be fence line. Now, here, if you choose to use straight line and join this, so you're establishing the polygon. But I always advise my students, when you are drawing this thing, draw it in such a way that as you are progressing, parts where mentally you notice that if you join this, make this look like a straight line, you try to establish something like a curve. That's what I mean. I'm still going straight here. So notice what I've done here. It's not like I'm forcing the curve. But when you look at it, you notice that it's like something that wants to go like this. I think it has more information to talk about. So it's you that is doing the mental adjustment. If you do your own, in a way that anybody that looks at it is seeing it to be just straight line, what you constructed is polygon. But this one is a curve. And this is what you are expected in most cases to do. This is what we call ogive. Some people call it ogive. So gradually we've come to the end of introduction to statistics. Everything we've done so far, if your research reads, there will be nothing outside. The only thing is just you not internalizing it. That is just for the introduction of statistics. So we are moving into measures of location, also called central tendency. So now that I have this, if I am asked to find anything median, percentile, name it. Okay, I will not claim this information because I've already constructed it. Once you are asked to construct median, quartile, decile in measures of location, in order for you to do it, I see some students that will come and do the frequency divided by 2 for median, and that is just it. No, that is just a position. To get the median, you will go inside that class, that position, locate it. And how do you do it? By first of all drawing this, then using a serious formula. This is formula for finding median. M equals to, that is when you don't have your graph. Because if you draw your graph now and do everything here, frequency, everything here is 37, shall we? 37 over 2 is what? If you have 15, that is around 17.5 or so. Shall we? If I have that, if I come to this place and locate 17.5, by the time I place this thing using my graph notebook, by the time I place this thing, then come and trace this thing down. Anything it gives me here, if you check the measurement, that's your median. You'll be very correct. But a situation whereby you are not with your graph notebook, or you want it to be very easy, fast, you will not come objective question, solve the median, you start drawing graph. So all you need to do in that case is remember that median can also be gotten by doing lower class boundary plus n over 2 minus cumulative frequency before the class the median is all over the frequency of the median class multiplied by class interval. Median is simply located. This is the mighty formula when it has to, the way you know mighty formula in quadratic equation. For statistics, this is an almighty formula. Simply lower class boundary plus total frequency n divided by 2 minus cumulative frequency before the median class. I will teach you what is median class as we enter measures of relation. Before the median class, all over frequency of the median class multiplied by class interval. Lower class boundary of the median class, total frequency over 2 minus cumulative frequency before the median class, all over frequency of the median class multiplied by class interval. This is the almighty formula of statistics. Do you know why I say it's almighty formula? See, why I say it's formula. Am I too fast? But let me slow down. I said lower class boundary plus total frequency all over 2 minus cumulative frequency before that class, median class, all over frequency of the median class multiplied by class interval. This is class interval. So it's not like saying do everything here, multiply by this, add to this. Do everything here, multiply by this. We will do it. We will get it. In fact, I will not use this one. I will claim so that I will do it step by step. Any example we use there, we use it. Let's not economize and maybe we limit our knowledge. So with that said, why I say this is almighty formula is that there is something called quartile under media measures of rotation. You might choose not to write. I will give you all those things. If we have something like quartile, if we hear quartile, anytime you hear quartile, it means something divided by 4. So if you hear first quartile, it's certain as 1 over 4. If you hear second quartile, it's certain as 2 over 4. But notice something, 2 over 4 is certain as 1 over 2. You see that too? And 1 over 2 is certain as something divided by 2. That's why we say that median, another name for median is second quartile. When I have third quartile, 3 over 4. When I have third quartile, 3 over 4, you can now see that if it's not median I'm talking about, if it's first quartile, I can just carry this 1 over 4. Let's say what I'm looking for is first quartile. I can just carry this 1 over 4. Go inside this formula, remove the over 2, and now put over 4. If it's first quartile. If it's third quartile, I can now carry this thing, go inside this formula, remove 4 to sorry, and attach 3 for third quartile. So it's 3 over 4 times 10 for third quartile. If it's decile, they can then come to the part where they're second decile. Anything decile means over 10. So if they say second decile 2 over 10, I can then carry this thing now, go here, remove this thing, put 2 over 10. If it's very, they tell you 12 percentile, it's said as 12 over 100. I can now carry this thing, come here, remove this thing, put over 100, put 12. So that is what we call this the almighty formula of statistics. So anything that we're going to be asking you to find as we enter measures of rotation, measures of dispersion, once you hear this of this, just go to this formula, can come out, put, you are done. So please, with that said, let's have an introduction, which is measures of rotation or central tendency. Measures of rotation slash measures of central tendency. So let's start from the beginning and do it properly so there will be no confusion. Measures of rotation slash measures of central tendency. So that measure of rotation is a statistical method. It's a statistical method which is used to find the center point of a distribution. So that it's a statistical method which is used to find the center point, or say the central axis or central pointing. So however you want to do it of a distribution. Now see what I mean by that. What do you mean by that? So I say it's a statistical method used for finding the center points, central axis, dominating points, key regions of a distribution. See what I mean by that? In this method of rotation, we'll be doing mean. When you hear mean is simply average of something. We have the arithmetic mean and geometric mean. We have the arithmetic mean and the geometric mean. So this mean in total talks about finding averages. And when you find average of something, you are simply trying to find the key one. So if I have 3 people now, if I do a practical 3 times, I will come and say add up the values, divide by 10. If I do it 2 times, so what you are trying to find is the main thing there. So more like a center. If you come, I've first started explaining this to the difference. If you come again under this message of progression, you come and see bold, what we call bold. We said that it's the class with the highest frequency. So if you notice, if it's the class with the highest frequency, it simply means that when I draw a histogram or a chart for it, you see that it's always at the dominating point. Once you look at it, it tends to direct you to an axis that this is the key thing. So for measure of location, it's simply pointing you to a central point. And the difference between measure of location and dispersion is that while measure of location tries to find the central point or the dominating factors, measures of dispersion tries to find the difference or the scatter or the distance from the center towards the edges. So that is what we say measures of dispersion talks about scatter or spread, while measures of location talks about central or dominating axis. So note that. So that is for mode. And you need to note that there's an important formula for this mode, which is L plus delta 1 all over delta 1 plus delta 2 multiplied by class interval. Here, delta 1 is simply frequency of modal class minus frequency, as we start some visual distance, of class before of the class immediately before it, because when I say it's all the class of class immediately before the modal class. Then delta 2 is simply equals to frequency of the modal class minus frequency of class. Frequency of class immediately or directly above it. So you don't use directly above it. So start taking examples to make more sense. Then the next one is median. I'm already giving you the formula for this one. So median tends to look at we normally say that it's a statistical method that looks at values above a data equal to the values below a data. So anytime I'm looking for the values that give me equilibrium for data above and data below, we are talking about median. So for a median, if I have, for example, a block here and I have another block this way and another block this way, this can only be the median if what I have down here is equal to what I have up here. So we say that median is simply the value, the statistical method for determining values that is exactly in the middle of a distribution. It's a statistical method used to determine the value of values exactly at the middle of a distribution. It's exactly at the center of the distribution. So if it's an odd, there are some examples I normally like avoiding because I see sometimes when you read some textbooks, they tell you about median, another day for median in the second quarter. Maybe they give you 1, 2, 3, 4, 5. They tell you the middle one is this one because this is even or even. This is even. Then you see you are left with this. What I mean by even is that if you check this, once it's an odd number, there will be one exactly at the center. Then you do this side and this side. For odd numbers, see what I mean? I have 1, 2, 3. Because total of this is 3, odd number. I have 1. But if I have 1, 2, 3, 4. You have 2 in the middle. And then you do these 2. Divide it, that is 5 over 2. That gives you the middle one, 2.5. But this is just an elementary part. There is no question ever going to be putting you to do median of root data. So the key thing you look at when you are doing median is always for root data. So this is maybe on root data. It's easy and it's too elemental. Nobody looks at it. So when we take root data, we now see how to do median properly using either the cumulative frequency curve or histogram. You use the two to get to median. Then the fourth type of location is what we call quartiles. Now, there's another one which we call interquartile range and semi-quartile range. I want to put it on that location because they are fall under measures of dispersion. Anything that involves me doing minus falls under dispersion. Note it. But I want to put it here to explain because it talks about me dividing quartile into 2. So I will say when you write interquartile range, stay open bracket and write example of dispersion. So it falls under dispersion. So I'm just trying to explain it here because as I'm talking about quartile, it deals with difference in quartiles. And don't think difference in quartiles under measure of location. Difference of anything, any of the major things we are doing that we are doing is under dispersion we do it. I just want to put it here because it has to do with quartile. What quartile is? I'll explain. So number 6, semi-interquartile. Please, any question at all, you come and attention. Interquartile range. And another name for this semi-interquartile range is quartile deviation. Quartile deviation. That's another name for it. So I want to bring, okay, yes, I don't want to touch this now because I will still treat each of them one. So just stop it. Then, let me clean this one. So remember, this is L plus N over 2 minus CL over L. Now, this one is L plus N over 4 minus CL over F. Or if it's Q1, which will call first order, or if it's second order, it will be L plus 3N over 4 minus CL all over F times class interval. So the second thing, so as a matter of fact, in wisdom, it's wiser to just say that this is A, B, and C to this. So we now go to number 5, which is decile, percentile. And under this percentile, let's say we have what we call maybe 90 to 10 percentile range. So this one falls under measure of dispersion. So but because I'm taking percentile that is under location, I'll touch it. So there you have it. So all those things like mean deviation, standard deviation, all those ones fall under dispersion. I could have treated it here, but it's too big. So I'll leave it for dispersion. So let's start with the first one. So write for me measures of location for grouped data. Measures of location for grouped data. Measures of location for grouped data. Measures of location. So example 1, that's what we want to do. Okay. Okay, before that, okay, let's do it. They say calculate the arithmetic mean. Calculate the arithmetic mean. Calculate the arithmetic mean using. You also need to note that another way to represent mode is like this. Another way to represent mode is like this. Calculate the arithmetic mean using. This is what they gave us there. X like this equals to EX all over N from the following set of numbers. Calculate the arithmetic mean using mean like that equals to EX all over N. So please, that place you note measures of rotation for groups data, right? Measures of rotation for groups and ungrouped data. So let's take the two together. Calculate the arithmetic mean using that from the following set of numbers. So I want to put in this, the three color of them. So this is the set of numbers. Let's write this. We have 31, 53, 65, 44, 72, 32, 46. We have 83, 43, 65, 36, 64, 43, 65. We have another one, 83, 62, 42, 48, 50, 51, 60. We have 26, 53, 52, 8, 28, 88, 56. We have 53. 64, 32, 48, 75, 67, 45. We have 52. 52. Okay, I think I posted something like this. If you check the group, I think I posted this. I posted a past question there. Check. I think the first question on the measure of rotation, that is the one I'm solving now. The first question there, just check the group. You see this I posted, you make the first day I asked once. The PDF. So this is what you have. Normally they don't divide it like this. I partition it so that as you are copying, you don't mix it up. So that's what you have. Now they said in the exercise, the A part of the exercise, form a group frequency distribution from the data. So as you've written this, they have said form a group frequency distribution from the data in question 1 above. Or you say in the distribution above. So form a group frequency distribution from the data or distribution above. Using the classes 20 to 29, 30 to 39, dot. So if you check the PDF I sent to the group, the first time I announced class. The first question there is what we are solving. So the A says from a group frequency distribution from the data. Now the B part says using the B part, another part again. The B part. Remember first, they started with telling us calculate the arithmetic approximative mean. Now they're telling us using, so it's another process that is telling us also using x equals to EFX all over EF. Work out the mean of the distribution. Then they said, can you tell why your answer to the question above is slightly different from your answer to the question? Am I too fast? Okay, you have the PDF. You have the PDF, right? Send it to her, but let me read it out so that as we are progressing, we have to be. So if you check the group, so that it will be faster, so that we can be faster. Because time reading question delays us, so that we'll be faster. By the time we have, if we're able to achieve everything today and next week Saturday, what that will be probability. It should be good to go. Alright, so see what I mean. If the question says EX over X, please, every value you have here, every value you have in this table is called X. It's called X. Divided by X simply means, if I check, this is like 1, 2, 3, 4, 5, 6, 7. Now, 1, 2, 3, 4, 5, 6, 7. 7 times 7 is 49 plus 1, 50. So this is like saying over X, or you say over N. Whichever one. It's the same as saying over 50, then sum of each of these things here. This is not the right formula to use for this kind of question, because if you look at this thing very well, you see that we have, for example, 60, let's check. We have like, for example, I drafted it out. I don't start stressing to check it. We have like, I didn't do that. Well, let's check how many times you have some values. 53, this is 52. It's more than once. The minute you see that a particular distribution is more than once, in your mind, place it as a grouped data. So the right thing you should have done is to just say, have a class for people that falls between this to this. Find out how many times we have it. But since it's not in that question, they told us using this formula. In that case, we can't group it for that first one. We must use this formula. And how to use this formula is simply sum of each of the things here divided by the total. So pause on it, everything here, add it all. Divide by 50, which is the total. That is you obeying that formula. That is you obeying the formula. So after that, we now do for the part where they said we should do it using classes. So what it means is that if they give me a table and they did not tell me, and they not put it in class, and they don't tell me to do anything, but they tell me how to solve it. How they tell me to solve it, that means what I will solve. So we use this thing to solve everything we've mentioned under negation. Once we have done with that, we do dispersion. Use one question there, solve everything under dispersion. Then we now go and practice the rest till next Saturday for probability. Probability is the word of peace. Probability is plenty. It's not something you do with these ones today. Because I have to teach you all those things they do head and tail. All those things, if it's not 3 times, if it's not this one, how do you go about it? I have to properly teach you all those things. Correlation. All those things like, if for example you go to the market and you notice that rain is falling in that period, the price of umbrella might even go high. The sales of umbrella will go high because it's rainy season. It simply means that rain falling makes price of umbrella going up. They increase. That is a correlation and it's positive. But if you notice that something is going up while the other one is going down, for example, let's say, for example, a man farms and as he's going to farm, his health, he doesn't check up, his health is deteriorating or decreasing. It's not like it's a consequence of that, but you can notice that his health is decreasing while his produce in the farm is increasing. You can say it's a negative correlation. So all these things are things we'll talk about in next Saturday class. So it's deep and it's plenty. So what we have summing everything here, everything up. 50. Okay, well, when you sum up, okay, you can't remember what did you get when you sum up? You already did divided by 50, should be 2,007 like this. Divided by that in the box. So divided by 50, what do you get? 5.46. That's approximately 55.5. Note it, we will note our value. Now let's go to the next one. The next part says form a good frequency distribution from the data. Now they said using classes 20 to 29, 30 to 39, all those things. So I want to clear this in because I believe you already have it in your notebook. So let me tell you this. So form a table. So what it means is class. So I can call it class number. The thing I should use 20 to 29. So if I use 20 to 29, then use 30 to 39, which means I can also have 40 to 49, 50 to 59, 60 to 69. That's how they want me to do it. They want the class width to be 9. That's why they said that 80 to 20. But the problem then is that somebody will not be asking his or herself, how do I know where to now stop? It's by checking the table. I noticed that the highest thing there is around 80, no 90 something. So I can stop at 80 something. So if you notice that I already did this, like I already checked that table. Check the table, you see that things that fall between 20 to 29 is like 3. The number of things that fall between 20 to 29, like here you have 20, 21 or 22 or 26 or 29. All of it falls within 3. So like it's 3, it's not more than 3. Check, you have 28, you have 26. You have 26 and then you have so how you do this? Come to the first row, check. The first row has 1. Check the second row, nothing. Check the third row, nothing. Check the fourth row, nothing. The fifth row is where you have 28. And you know, horizontal, how I remember it. Anything like this, horizontal. If it's follow, so remember it. It's not vertical. So going this way, that is how I'm doing it. So I have just 10. So if you run it, you see that I won't be wrong to put that. Check it goes, you get it from the top. So you get 4, so you get 10, so you get 13, so you get 11, so you get 4, so you get 5. If you check all those horizontal lines, what is that? Each of these, from 80 to 89, that is the frequency you have. Now that I have this, a way to do something for yourself is to simply call. Immediately you get to this point, just come and do your class mark and move. Because I told you, once it's bounded, once the S class bounded, X gets replaced with M. Class mark, midpoint. So now, the midpoint here is simply add these two or divide by 2. You see that you get 49 divided by 2 should be 24.5. So if you add this one is 69 divided by 2 is 34.5. 89, 44.5. So you can do it for all. 109 divided by 2, 54.5. 129 divided by 2, 64.5. 149, 74.5. 169 divided by 2, 84.5. So this is how to go about it. For any group data, you must always find the class mark. And that's it they said that if you finish, we should do EMX over the summation of F. The X in this when it's grouped is the second as F. So note that. Remember we said that this M is the second as X. Was that I am saying my method is saying if it's ungrouped, use X. If it's grouped, know that it's man. Even though mathematics puts all of it to the X, but knowing this basics is something you remember. So if I've noted that, I can now come and say, at this point, you now have Fx, or you say, since I'm using this is a group data, I'll not use Fx, I'll use Fm. If you want to use Mx, no problem, but just remember the reason why you are doing what you're doing. Now come and do 3 times this. Here in your calculator. What do you have? 70. 73.5. Do for me. 4 times 34.5. 1. I can't hear you. 138. Okay. Got 445. 13 times 54.5. Huh? 7. Okay. Times 11. 7. Okay. 709. White. 7 colors. Okay, don't do this like this. You are 74.5 times 4. 29. 84.5 times 5. 4. 40. Okay, so now that we've gotten this, you see this thing like this thing means summation. Here means summation. So anywhere you see this, don't mean add up. So now add up everything here. Add up everything here. That was 50, this one is 50. Then add up everything here. By the time I go with today's class, you should know everything from statistics introduction measures of location, measures of dispersion. It will now be remaining probability. And inside probability we have the logs. We have the logs and we do it. So add up what we have. 2735. 2795. Please confirm. It's correct. Okay. Now EFF over here. It was 2795 over 50. I have punched it in your calculator. You got it from you. 55.9. Okay. Now notice something. You notice that first one, we got 55.5. Here we got 55.9. So you can see that using group data, we are having, if you run this up, if you run the first one, it's still 56. That is one is still 56. But you can see that we have an extra. Like, it doesn't really make, should I say, because it's 4 to 5. Assuming it's like maybe I got this to add up to 66. You see, whenever you have something like 0.4, we use 0.4. I believe the 30-second school. If it doesn't exceed 0.5, it means that they are the same, they are equal. So for that, it's still the same result. But what this one is showing is that it's counting for an extra. So he has more accuracy because more decimal point, more value you have after a decimal point means more accuracy. They will tell you, if I have, for example, 0.9024, using it to solve, it will be more accurate than someone that just solved using 0.9. So after a decimal point, more of values you have, tells more accurate your work is. So what it simply means is that when it's grouped, the tendency for accuracy is higher. That's just what I'm trying to say. So it's the same result, but the tendency for accuracy here is higher than when it's ungrouped. That's what it does mean. So check the next question after this. So if you solve grouping it, solve without grouping it, you still get the same answer. But what is this? If accuracy is really required, so please, we've gotten the mean. The mean is given by x that is having half and top. Why when is x having a caret or carrots, we call it mode. What's the next question there? Check. I want us to answer all the questions then use this same question to answer everything on the list of measures of location. So check. What's the next thing you ask us to find? Is that all? Okay, it's simply because this one is a group data. The other one is an ungrouped data. That's just the difference. So because this one is a group data, while the other one is an ungrouped data. That's just the answer they want you to give them. So that means we can now go ahead to use this to find we've gotten mean. Let's find mode. Find median, find quartiles, find the things under that are related to what I decided. So in order to find mode is simply said to be the class with the highest frequency. If you check this is frequency. Which class has the highest frequency here? 50 to 59, should be? So if I say state the class with the highest frequency or state the modal class, you are just going to do 50 to 59, that's just it. But if they say find the mode of the distribution, you will not come and do. It's either you are using your graph to use that histogram to find it, or you are using this formula equals N plus delta 1 all over delta 1 plus delta 2 multiplied by class delta. Either you use histogram to find mode, or you use formula, which is this. And whenever you are using histogram, it's required that you have your graph. may be able to see the points. So now this is going to be, if I'm going to be using this, I will simply say lower class boundary for this thing now, lower class boundary for this should be 49.5. That's for this class now. 49.5 if they need to for this thing. 45. Yes. Now there are one who say the class before this lower class, the class before this lower class, the frequency is 10. It's 10. Before this lower class, the frequency to this class before it is 10. Why the lower class frequency is 10? So we do 13 minus 10, which will give us 10. Now call it again for the other 2. The class after this lower class is this class. The frequency of this class directly above lower class is 11. And this one, lower class is 13. Between 13 minus 11. This is 2. Now, if I've gotten that, I'll come as now. My eye class interval, difference between the successive upper class boundary. This is 39, this is 39. 39 minus 39 is exactly as 49 minus 39. Which is 9. So this is going to be plus just 3 over 3 plus 2 multiplied by 9. So watch it for me. This is how you find mode. Because some students will just say the mode 13 or 50 to the you still see that you will get it wrong. Reason is because they expect you to know this formula or to use your histogram and find anything you get here. If you go and plot a histogram for this distribution, I know that histogram is wrong using frequency and class boundary. If you use histogram and plot it, by the time you finish, now project down. Anything you get solving this is what you get at the abscissa, the horizontal side of your histogram. So divide by this, do 3 over 5, multiply by 9, then you add up to 49.5. What do you have at the end? So always think, right?
What did you get on that?
9. Class interval. Class interval is the difference between successive upper class limits. So I normally mistake and call boundary, class boundary. It's by putting trouble. When you are looking at class interval proper, it has to do with upper class limits. So remember, it is not like we don't find interval from upper class boundary, but proper. It's simply got to like the difference between successive upper class limits. So see, if you look at 9 minus 29, it's the same as if you do 49 minus 39. Is it 10? Okay, it's 10. Away. What am I doing? You can go. I ate before coming. My eye was just looking at 9. I forgot. So punch for me. What do you have? I want to tell you this. We've gotten in already. Bracket first, multiplication second, then add. What do you have? 55.5. That's the mode. Remember, there is no unit. Mathematics does not look at units. It's physics that looks at units. I will say unit is a standard for comparing or expressing physical quantities. In order for you to identify what quantity it is, we use units. So yeah, mathematics doesn't talk about quantity. Progress is all yourself and value together. So the next thing is to find median. To find median. That's the next thing. To find median, will clear. Let me clear. I always tell my students, you cannot find medium without doing cumulative frequency curve. Forget this one, you will go online. People that understand this properly will just come because they've already solved it. When they are teaching you online, they are going to do the medium will not be in this class. You will be running one hand. You know, there's person, what are they doing? It's because anytime you want to draw medium, you need to draw a cumulative frequency curve or a new slogan. Cumulative frequency curve is faster. It's faster. So all I need to do is to simply say, I want to. Please, I want to rewrite this here. Because it normally confuse me. Please, it's still the same thing. I'm just writing so I can see. Now see, that the cumulative frequency is the same thing. In fact, in order for us not to have issue, alright, let's go. The first one will be the same. 3 plus 4, 7 plus 10, 17 plus 13, is it 30? 30 plus 11. Which one? Okay. Shall you see that our class cumulative frequency is the same with this summary? Very important. Very important. So it's not hard. It's just something that if they bring to your notice with time, it becomes part of you. Okay. Now see. Get me the upper class boundary. You remember, what did I say you used to draw cumulative frequency curve? Cumulative frequency and upper class boundary. Please, don't be a copier. Don't be a copier of the word. Also be a rememberer or a memory space for the word. So let it enter you out of it. This one will be 39.5. This one will be 49.5. Any confusion, you will call my attention. Please. That's why it's called statistics class. It's very simple, just that you have plenty numbers that you're looking at. So then I can use this to plot together. I have my zero. I remember we said that There you have it. Then the cumulative frequency. So I have, let's start this 5, 10, 15, 20, 25, 30. So if you understood the first one, it's the sentinel wave. That's it. Now then come and point, mark out my points. Just do I do the first one. So I'm not taking mine like this, like explaining. So this is 3. Over here. 7. This is over here. 17. So please, I believe you might know how to work with the difficulty, so don't need explaining this one. And when you get all the difficulties, it's not. Let's get somewhere here. So, write the points. You do your own well with your meter measurements. You should correspond well. See each other. I know I made some mistakes in my measurement. But even if it goes anyhow it goes, it's not going to be a business, but I'm just believing that there are some things I didn't do well. I think it's drastic. I believe if you do it properly, it should be something like this. So do it. Now that we have this, okay. Now that we have this, to find median, I do for me. This is the frequency 50. 50 divided by 2. 25. N over 2 equals to 25. Remember that if that is the case, I will come here. And please, why is it important to do this thing properly? Like, measure it properly is that it helps you find out the class that your value is in. You can't find it from the table. So it's from here, the value is in. So at this point, anything on your graph that you read off here is your median. Anything you read off here at this point is your median. Now that you've gotten this, if you are not using graph, how do you get to using the formula? All you just need to do is to now come and say, this thing helps you find a class. Actually, you are not with your graph. You must draw this thing as well. But the only thing is like, it has not found out that it's in a class of 49.5 and 59.5. You now come and ask yourself, if I have 49.5 as a lower class boundary and 59.5 as an upper class boundary, which class is this? Which class on your table now has upper class boundary to be 59.5? So this is this one. This is class. Because lower class boundary of this will be 49.5. So if that is the case, all I need to do is I'll mark it out something. I've loaded this. The reason for noting it is that I can now come and say, using this formula, M equals N plus N over 2 minus CF over F plus interval. I will now come and say, this cumulative frequency here is actually the cumulative frequency of a class before the median class. And notice, before this median class, what is the cumulative frequency? Remember, this is the median class. Before it, the cumulative frequency was 17. So this is the reason why, even if you are not using your graph notebook and you are drawing this thing, you need to draw it well properly so that by the time you trace the class, there will be no mistake. It will tell you the class, because that class it tells you is where you will find the cumulative frequency before that class and then the frequency of that class. So this CF here will simply be 17 minus N over 2 is exactly as saying 50 total frequency divided by 2. 25. I have 25. Then the frequency, this F, will simply be the frequency of this class. And this class frequency is 13. 13 over 13. Now, the class interval of this distribution is 9 minus 9. What then? Because the lower class boundary of this class, if this is, remember, is simply 49.5, which is this. This is how you will always do it. There's no place in the world you now come, start doing something different, start adjusting to know. Once you're able to go, master these methods, solve any questions that you have here using this method, you will always be correct. You will always be correct. So this is how to about it. I see why I'm taking my time to study this student. I see some students, what is bigger? They just list over this 25. That is it. It's wrong. That 25 is simply saying, okay, you've got 25. Go inside that class and point it out. It's like a position. So now solve for me. 25 minus 17 over 13 times 10. What do you have? You see 510? Okay. So we got, come again. 5.6. So approximately 55.7. So what it means is that if you are using your graph to mark this thing down, by the time you come and check here, then your graph goes through, the measurement you will have here will give you 55.7 or 55.65. Are you getting it now? Assuming this thing is a graph notebook, by the time you check all those dotted lines, you see at this point here, it's graph 55.65. So, but when you use your formula, this is what you have. So, if you are not with graph of objective sake, all you need to do is be able to locate the class, then use it to solve. So, we've gotten the mean, the median, we've gotten the mean, the mode, the median. The next thing now is to find the quartiles. Okay. now, the class, and maybe you are not using graph, you just get that it's in between the classes, just like we've done now. Carry out that class. What you just do with this is to know the class, so that you can be able to find the cumulative frequency before that class, and then frequency of that class. Because without doing this, you can't know which class media is. It's not like mode where you just say the one that has the highest frequency is the mode. You can't know the class. So the only way to know the class is for you to do this thing. So as you practice, whichever one you find fastest, you go with that one. So in order to do the next thing is quarter. Next thing is quarter. In order to do quarter, anytime you hear quarter, it means over 4. Anytime you hear quarter, it means over 4. So if you hear first quarter, it means 1 over 4. Second quarter, 2 over 4. Which is the same as 1 over 2 median. Third quarter, 3 over 4. Now if I plotted this, you can see in objective question where they ask you, another name for third quarter is what? Upper quarter. And you can see why we don't have 4 over 4 is because once you do 4 over 4 is 1. So it ends at 3 over 4. There's nothing like 5 over 5 over 4. If I've noted that, you now need to know that if I'm to find the Q1, which is also called lower quarter or first quarter, another name for first quarter is lower quarter. Third quarter, another name for it is upper quarter. Those are these things. Now, if I've noted this, I'll say 1 over 4 times the total distribution. Total distribution here is 50. Now, it's total frequency, and it's the same as saying n over 4. So 50 over 4 is the same as 25. So this is 12.5. Check. 12.5. So if I've gotten 12.5, all I need to do is to calmly go to my graph now. So apart from mode, every other thing you need to find will always require you to know your cumulative frequency curve. Histogram, you can use histogram to get median, but you can't use it to start doing quartile to break it down. That's why I said cumulative frequency curve is the one you use to get everything. So you can now come here, locate 12, let's say this is, let me divide this in between quarter. Let's say this is 1, let's say this is 2, 3, 4. So this is 11, 12, 13, 14, 15. So this, if I trace this straight line, what we are doing is not man, this is how we should be done to always be correct. Any other method of doing this, like telling you, yes, this one, is just proving methods by someone that already knows this one. So, and those proving methods are like shortcuts, and those shortcuts don't work if you don't know this. Because I can easily tell you, when you find mode, the possibilities of you finding median in the same class is high. I can tell you, like, somebody that understands this will tell you that without solving, anywhere you find your mode, the chances of you finding median in that class is high. If you check other distributions you do, anywhere you find mode, it is likely you always find median there in that class. Are you getting the point? Because for median to be dominating, it simply means it's more like the central region. So, but in some examples, when the discrepancy, maybe the class interval is 2 times, it might change. So that is why before those shortcuts, you need to understand this. So from it, now when you do it plenty of times, you can now start using the shortcuts. Make sure it's straight line. Make sure it's straight line. My own is shifting somehow, but when you're doing your own, straight line. Correct. So now, at this point, if you are using your graph notebook, any point you find here is your Q1, your first quarter. At this point, any point you find here is your Q1. So once you just come, you check it, read it up. This is the type of check here. Any points here, read it up. That's your Q1. But for the fact that we are here, we will now use our formula to balance things. So I can now say, using our formula, actually I just did on a rough notebook, using the one doing it now like a rough notebook. And I come and say Q1 will be equals to L plus N over 4 minus CF all over F times class interval. And you know that this N over 4 we got it to be 12.5, shall we? Now, if this is the class that has 39, I come and break out the class that I have here has lower bound of 39.5, upper bound of 49.5. Now, which class has upper bound of 49.5? This is the class because lower bound of this class is 49.5. So it falls inside this class. So you know one thing, like one thing you will notice as you progress for the sake of the exam, solve, but one thing you will notice that your first quarter will always come a class immediately before the modern class, and your what's it called, third quarter will always come a class immediately after the modern class, and your median is likely to fall inside the modern class. Like as you start solving, that will become a shortcut. But if you notice that sometimes you tend to go as if you are, should I say, closing your eyes. That's why I'm asking you, I hope all is well. Because you don't have to force yourself because you want to learn when you're not feeling fine. Okay, so that's like a short string, a shortcut. But practice these ones first before you now adapt to it. Myself, if I'm solving any of these questions, I don't need to be doing all these things. With these shortcuts, I will always be correct because if the gap between the class interval is like 9, it's not like the class width is like 9. That means this my shortcut will always work. Or if it's too big, it will always work. But if it's too small, that means I really have to obey this one. So that's it. This cumulative frequency here is simply the cumulative frequency before this class. The cumulative frequency before this class is 7. It's always the cumulative frequency you're using is always the one before the class is 7. Now, the frequency of this class is what? 10. Shall we? 10. Now, the class interval is the same for all. It's 10. Then the lower class boundary of this class will be 39.5, which is here. So watch for the here in your calculator. What do you have as yes? Eh? I don't know. Which one? Is it the Q1? This one. Okay, is it after cutting it from here? Why am I solving it again? Which one? Eh? Like what is I'm solving again? We've not got Q1 now. What we got before was Q2, or you call it median. What we got before was median. That one that we saw first, the one we saw here is median. So what we are doing is like two things. We are saying when we are using graph to solve it, and when we are using the formula to solve it. In order to use the formula to solve it, we need to go to this graph part or this drawing part and locate the class. Then now come back to the formula. So but if you are now using just graph to solve, you don't need to locate or use any formula. Just anything you find as you pointed and marked down is just it. So what you have as your Q1, press minus divide by 10 times by 10, then add 45. That means that by the time you point your own down, what you have here will be 45. It will stop at 45. That's it. So now for Q2, upper class, quartile, upper quartile, or say top quartile. So for upper quartile, I want to do it. Can I do it? In order to find upper quartile, which is Q3, all I need to do is to say 3 over 4 times n. So if you do 3 over 4, it's 0.75. Around 0.75. Just do it. Then any total of frequency, any total of frequency. So 50. Punch for me, what do you have? 3 over 4 times 50, what do you have? Eh? 37.5. That's what you got. To show. Now see. If this is 35, let's do the same analysis we did earlier. Let's say I break this thing down 1, 36, 37, 38, 39. Let's do more creative. Now I was passing through hostel side today. I noticed they put GP time for hostel people. Is it true? Is it since when? No, I mean that's GP time here. Since when? Since you came into the school. No, I mean that one that is in front.
That they were feeling.
Yeah, they were feeling. Because I've never seen the tank being filled before. It's just like that. When I saw it this morning, I was like, wow. They are really playing the politics well. I like that. But the worst part is that the day of the election, people will just stay in your house. And the worst part is that they have now introduced face scan on profile. Because before, how they do it is, if students refuse to come out to vote, some of them will use students' data, enter their portals, and be voting for themselves. That's why law faculty in this school has produced more, should I say, winners or more executives, because they know how to do that thing very well. But now that there is facial recognition, it won't work again, because every student needs to be present. So see, this is 36, 37. So if between 36, 37 and 38, I should have 37.5. So I'll place this straight. Let's say I locate this down to straight line. Then you use to do that to draw your result. So it's the line you're drawing, straight line. So from here, there's a short trick. The short trick is simply, if you don't want to be stressing yourself, you just want to use the formula. Your modern class is likely to be the same with your median class. Median is represented as Q2, second quarter. And then your Q1, your first quarter class, Q1 is likely to be the class before modern class. Now your modern class. And your Q3 is likely to be the class after the modern class. You don't see this in a side textbook. You can only find it in this class, because when you solve many questions, with time, you come to start realizing something. That's what realizing certain shortcuts. yourself to be doing, you do all this table, drug cumulative frequency curve, and somebody that came for my tutorial, you just remember that model class will always, provided the interval is high, will always give you median class. Then use formula then to balance things out. So now that I've done this, I'll now come now using that formula Q3, and I say Q3 is equals to L plus 3n over 4 minus cumulative frequency before that class all over the frequency of that class times class interval. Now 3n over 4, we got it to 37.5. So I put 37.5. Now, the class after the model class is this one. So you see it. Because if you check, this is 9.5. Upper class value is in this class. So, if I've noted this, I'll now check what is the cumulative frequency before this class. That class interval. So there are many shortcuts in this course. If you learn this course very well, shortcuts are plenty. That is why I tell students, when it's maths of statistics, you have many shortcuts. Maybe you don't need to be solving anything self. As you progress, you will be solving. Now the frequency for this class. You have to show me? So now, Q3 will be equals to, so one time, remember, the lower bound of this class, 59.5. Lower class bound. So now, watch on me, solve everything. 66.3. Okay, so that means that we solve, we got this. If you use your graph, you just get this. Very simple. So now let's move to the next one, which is decile. Let's say we are asked to find the 16th decile. Let's say we are asked to find 16th decile, 25th decile, 80th decile. What it just means is just 16th decile means 16 over 10 times n. So 25th decile means 12 over 10 times n. 48th decile means 48 over 10 times n. So when you locate it, you can come to this place, find it out. Let's do it for 16th decile. So that it's not just explanation. Can I terminate it? So remember I said that this is the short cut. In order for you not to use the relative frequency for objective. So we will learn the main method and the short cuts. You can just use local cuts there. It will always work for many distribution. A lot of the distribution, it will always work. The only time it won't work is when you notice maybe what you have is like maybe you have the gap to be, let's say 2. Let's say the gap is like 2, 1. But provided the gap is large, it will always work. So you try to make examples, you see that it will always work. The other class will always give you the same class with the median. The Q1 will always be the class before the modal class, and Q3 will always be the one. So now, you can't find that side. Why? He's giving you 8 because we use 25th. Let's check and see. You did 16 over 10 is 1.6. 1.6. Let's say I went too far. It depends on what they ask you. So if we can't find it using this, it's simply because I gave you this using my head. So 1.6 times the total of n is what? 8 there's anything percentile, maybe 26th percentile, 99th percentile, the chances of getting 1000 percentile is very low. Chances of getting anything more than 100 percentile is very low. So that's what I mean. So if we're finding second percentile, we do 2 over 10 times 50. Like 7.2 times 50, what we have? 10. So this can work. Anything between that 0 to 9 will always work. So if it's more than, it depends on the chances. But just have it in mind, that's why you're in tutorial class. You are actually never going to ever see a waste of the statistics that will tell you to find above the ninth decile. That's what I mean. It's always been from 0 to 9. And you are likely going to never see in your life any percentile that is above 99 percentile. The same way you are likely never going to ever see any quartile that is above top quartile. So it always fall in between what that thing you are dividing is all about. So if this is 10, this one is giving us 10. All I need to do is to now say, since he gave me 10, I will come here. By the time you check your value, the value you have here, this is going to be the second decile. Or you say D2. You either write it as D2, second decile. This is going to be your D2. Or if you don't want to use it like that, you can now just note the class. You can just note the class. So if you notice that class, notice that the class is in the first quartile class. That's the class before the modal class. So if you notice it, you can then go back to use this formula. This is our formula. So this time around is D2 equals to L plus, so now it's set as 2 over 10 times N, or say 2 over 10N minus CF all over F times a class interval. Remember I told you that this is the almighty formula of statistics. So once you have to do anything at all, it's always there. It's always there. All you just need to do is to check this first one. So the lower class value for this is simply 39.5. And 2n over 10 give us 10. Yes, because it's 2 times 50, which is 100 over 10. Yeah, that's correct. So then the relative frequency of the class before that class, and this is the class. This is the class that has that type of thing. The relative is 7. Class interval, difference between two successive formal class values is 10. 39 minus 29 is 10. The frequency of that class is 10, shall we? Is it 10 or 4? 10. Yes. So, there you have it. Punch, anything it gives you, that's it. Huh? 42.5. So that's your second decile. So if they ask you the 100th percentile, the same approach. Do that thing. Sorry, let's say they ask you 99th percentile. Let's check. 99 over 100, what is it? Then times it with our n. Our n is 50. Times what do you have? 49.5. So we have 49.5. Okay, I'm coming now. Now we can then come here. You can see that it's easy for us now to come here. At this point, if this is 46, 47, 48, 49, it's easy for us to get 49.5 somewhere here. Just get that. And when you get that, so straight line. I don't know if this is straight enough. Right. You know that when I was drawing this thing, I made some adjustment here that was a bit less. So now at this point, locate this. So somewhere around this is giving that. I believe it shouldn't live. But the key idea is simply you using whatever value you get by doing that division to locate the class. Now when you located the class, you carry it into this formula. And so that is all about what's it called? Measures of location. But notice something. Under the measures of location, there's a place where I pointed out interquartile range, semi-quartile range. So yes, because we don't know what quartile is, and we don't know what first quartile and second quartile is. So then let's talk about interquartile range. Remember I told you interquartile range falls under measure of dispersion. But you need to know that whenever I hear interquartile range, IQR is simply first quartile, just like that. So if this one's first quartile gave me, so the third quartile here, what do we get? That time we saw BQ3, third quartile, BQ3, you got 6.3 minus Q1, they are not participating. You don't have calculator. 40, 45. Oh yeah. So punch for me. IQR will then be equals to a punch. 20 to 1.3. That is my interquartile range. It falls under measures of dispersion. But when I'm treating it here, because we use things for the location to do it. So it's simply the difference between upper quartile and lower quartile. This is lower quartile, also called upper quartile. So what it means is that if I have, let's say, something like this, and I divide this like this is going to be Q2, the main here. Why this part 1, this part is going to be the Q1, the next quartile. Why this one is going to be the fourth quartile, Q3. That's why we call it upper, lower. So we've noted that the semi-interquartile range, which we also call quartile deviation, is simply IQR, interquartile range, divided by 2. Interquartile range divided by 2. So it's simply the same as saying 21.3 divided by 2. So interquartile range is simply Q3 minus Q1, that is upper quartile minus lower quartile. While semi-interquartile range, which we also call quartile deviation, is simply interquartile range divided by 2. In some textbooks you see it like this: Q3 minus Q1 over 2 is the same thing. So punch, what do you have? 10.65. So that is all for measures of location. So the other questions here, anything you are solving here is still the same thing, but the only difference is that in this one they might ask you to solve for this one, but we've touched everything. So let's quickly touch measures of dispersion, so that we'll call it a day. After measures of dispersion, we will be sure we've done introduction to statistics, measures of location, measures of dispersion. Next Saturday, we'll now do probability. Probability is a word of this whole, because under probability we'll be doing probability, events, mutually exclusive events, independent events. We'll be doing permutation and combination, binomial theory, correlations. So it's a very big word of this whole. So let's move